Okay, so like I said, the first thing that we're going to do here is find the middle, just like always, and it should be fairly similar to all of the papers I've given you. So 3 1/4 or 7 1/4 is what I've got here. 3 1/2, 3 1/8 makes that my center mark vertically. My scale is 10 1/4, which means 5 1/8 is my center mark going this way. Alright. Okay, so even though finding the center mark for an isometric drawing is important, it's not actually the most important part to complete an isometric drawing and have it fit in the space that you have available. So if we look at the drawing that you have, you'll see that it's 4 inches deep, 8 inches long, and 2 1/2 inches tall overall. And very similarly to how we would draw our orthographic projections, when you create your isometric drawing, you want to create the box that your shape would fit in as well. The only difference is that this time that box is going to be a rhombus, basically. So the first thing that I'm going to do is I'm going to come down from my center point. Because my shape is 4 inches by 2 1/2, I'm going to come down half of that distance when you add them together. So I'm going to come down 3 1/4 from my center mark. So if I put 3 1/4 inches there, this is not really a perfect way to do this, but it is a good general rule of thumb in order to make sure that your entire shape is going to fit on the shape or the page. The other way you can do this is to just come down and measure that that right hand side of your drawing. So if we look here, it says it's 4. If we can fit our 4 inches on the page, you can smash it as close to the bottom as you need to. So I could just do this right here and be just fine. The only difference is, and that is basically what I'm going to do for this, the only difference is I'm going to start that 4 inches so that it comes in even with that line we measured just a minute ago. So the mark I just made is 3 1/2 inches down, and then I placed the 4-inch mark on my triangle on that, and my first line is going to be 4 inches up along the height or the angle of the triangle here. Now, when you're drawing an isometric, the key thing to remember is that all of your horizontal lines become 30-degree angles. So essentially, the first thing I'm going to complete on this is I'm going to draw what would have been the right side view of my orthographic projection, but all of the horizontal lines are going to become 30-degree angles. And I'll show you what I mean right here. This is a 30-degree angle on my triangle. I've got 4 inches. I'm going to go ahead and mark that off 4 inches up to that point there. Mine got a little squirrely at the end there because the end of my triangle has been broken off. So I don't have that sharp point at the edge, so I had to fub it a little bit. Okay. The other thing you have to remember about isometric drawings is that all of your vertical lines are still vertical lines. So I've got my 4-inch 30-degree angle. From each side of this, if we look at our drawing, you can see that it says that rectangular block that makes up the bottom of this is 1.5 inches tall. So that's what I'm going to do next. I'm put my parallel rule on the bottom of my line and draw an 1.5 inch tall line on both sides of this. So point there and point there. The next thing that I'm going to do is lightly create a line across between those 2 points. And I say lightly because I'm going to have to erase the middle of it. We need to figure out one other thing, though. So if we look at this drawing, you can see that the overall height is 2.5 inches, right? And the height at the bottom is 1.5 inches. Which means the leg of that 45-degree cut-in is 1 inch, right? And what do we know about 45-degree angles? Well, let's look at your 45-degree triangle. So that's this right here. And we know we aren't going to use this one because the angles, while it says it's 45 degrees on our drawing, the angle is not actually 45 degrees because it's been skewed. But that doesn't change what we know about this angle. So if we know, let's say this whole thing here is 1 inch. What do we know about this? What are the properties of this type of triangle?
Yeah, they have 2 sides that are the same.
Exactly. So since we know that this is 1 inch on this side, we also know that this is 1 inch across the bottom, right? So what we're going to do on here is we're going to come in 1 inch, and we're going to darken a line in for that 1 inch on both sides. Okay. And then you can take this time to erase the rest of the center because you won't need that anymore. I would recommend using your erasing shield even though I didn't just then. Okay. The next thing that I'm going to do is I'm going to set my triangle back up this way so I can measure vertically again. And I'm going to measure up and put a mark 1 inch above the vertical line that we've already created on both sides. Okay. And then all I need to do is 3 lines to finish this shape. Since I'm already here, I'm going to connect those 2 dots that I just made at the 30-degree angle. And then I'm just going to use my straight edge to connect the remaining corners. Let's see. So for this view anyway, this is exactly the same thing that we did to create the I should have done this at half scale. This is not going to fit on this paper. Oh well, it's fine. This is exactly the same shape as the right side view of the orthographic projection of this shape. Just, like I said, skewed up to 30 degrees. Now if we look at this paper here, you'll see that it says that it's supposed to be 8 inches across going along the front view. And one thing you're going to notice is that 8 inches is definitely not going to fit on this paper, not even close. So we're going to change that number to make up for that. And we're going to make it 5 inches across, not 8. Okay, so on here, just write it in so that that 5 or 8 is a 5. And we're not going to change anything else. So the next thing I'm going to do then is I'm going to complete the top view of this shape, which in this case is just a flat rectangle. It would have hidden lines if we were doing this orthographically, but one thing that you need to remember is that you don't do hidden lines on isometric views. So because we changed that to 5, I'm going to set my 5-inch mark on this upper corner and draw out. Same down here at the bottom. Draw out. And then flip my triangle over long ways. And connect the two. Okay. I'm actually really close to being done with this. There's only a couple of things left that we have to do. And most of it involves drawing out more of those 5-inch lines. So basically both of these points also need to have 5-inch lines drawn off of them. You know, I'm going to burn an inch so I stop messing with that corner problem on my triangle. If you ever hear me say that I'm burning an inch, basically that means I'm moving an inch up my measuring tool, because the least accurate part of any measuring tool is going to be the end. In this particular one's case, it's because that end has been broken off. In the case of something like a ruler, it's mostly because it's a lot harder to read that end. And then the last thing I need to do, since I've still got my triangle in this orientation, is just take this corner over here and draw it back to that line that we've already got created right there. Just need a vertical line. And there to there. Okay. So admittedly, this is a fairly easy shape to do. And that's why I chose it for your first one especially. But this is why we do it in this order. It's why you do the orthographic drawings before you do the isometric ones, because it literally is. Two of these shapes are literally exactly what you would have done on an orthographic projection, just turned 30 degrees in both directions, right? Alright. This is Lab 11, so once you've got this finished, go ahead and I will get the Lab 11 turn-in popped up here in just a minute, if I didn't do that already. It should be available, but I need to change the drawing that was a part of it. Draw the... I should probably... And that's it. That's finishing this drawing.